work. We had when it came to is making connections. But in essence, this was about 5 days worth of development with 3 developers. So if you think about it, it's relatively fast. And to put it in perspective, we did the entire diameter stack in 3 months. And that took a little over a year. So this is fast. Because Surface enabled is we're able to handle messages at a much higher rate than the devices. And our latency is 250 microseconds. So you worry about interjecting this mediation layer into your application. You're going to worry about, like, for example, in your application, post out delay. And because it's microservices, we can see the smallest deployments, and by just automating the application going out and grabbing more threads, more memory, more CPU, is this. So if we were to deploy this into my cloud, is as you guys bring on customers, you would use this application computation power as you need to. So, for example, New York City starts to fire up 6:30 in the morning. That microservice layer would expand, and as New York was kind of wrapping itself down at night, it would contract.
Hey, David?
Yeah.
It's Richard. A quick question. You said 250 millisecond latency.
Correct.
Is that
microsecond latency.
Okay, microsecond. Okay. Okay. Thank you.
No, I'm glad. Thanks for asking. We think milliseconds is a long time.
Yeah. Holy smokes, that's.
You like meeting's over. I can go get a cup of coffee.
Yeah, that's what I was thinking. All right. Hey, thanks a lot. All right. Nice demo. See you.
Yeah. And on the way is Kalidas' team has built this 100%. You'll see a server in this room. The server is nothing more than a T-server, but this is all built on a cloud-based infrastructure. So, you guys want to put it onto an existing hardware platform at a customer site, that's great. If you put it into your cloud, that's fine. The thing here, kind of generating it, all right? And I want to kind of show you really quick. This is really the architecture, and the architecture, if you think about it, is on one side is going ahead and having a skinny cluster, having a SIP cluster, having a Unisim cluster, having a unified cluster on the left side, and then the translation and DB engine. So the way it was really built, and he'll walk you through it, was...
Just to clarify, it's on the left-hand side, right? So obviously Skinny would be the Cisco, then for business would be the Microsoft, Unistem is Nortel, and then we could also add, potentially Mitel, right? The MyNet protocol. So, I mean, really, this is just a starting list. I mean, you add a lot more. For each block, there will be unique features. Yep. And then I sent you that document with about, I think it was 25 features, legacy features. So the big question would be how quickly, would you, implement those features per different vendor stream, right?
Yeah, and let me kind of dig down further. We've discovered that and again, there's no domain knowledge when it comes to in the engineering team in regards to SIP or these signaling protocols, right? So we stumbled on a few things, but we kind of recover ourselves. But along the way, what we realized is even Skinny, there's a whole different sets of Skinny per telephone. So you can think about having a microservice for each version of SIP, or especially in a cloud infrastructure. If something was to change, like for 960 G phone, it would only affect that microservice. So when we go back in order to correct the mediation, you wouldn't have to worry about like a monolithic architecture where you have to rewrite the code and then republish it. All you do is correct that microservice and bring it up. It allows us to kind of go forward and scale it, but it also allows us, as you guys run into issues, and let's be honest, we're in technology, issues happen. Changes happen, for example, on the MX1 side, changes happen on the Cisco side of the code upgrade, is we can recover very quickly from it, and we'll show we do it. And again, the proof is in the pudding. We'll tell you in the demonstration.
Yeah, to reinforce David's point, only what we have is, so we have, like in the earlier slide, we have a protocol wrapper, middleware. Basically, what we do for each of these products is, right, I think that slide is not here.
Yeah, it's not, sir.
So what we do is basically in the middleware, we write these FSMs, finite machines. So each phone represents a finite state machine. So if you have a phone, Skinny phone's call states and the features, the 25 features you are saying, right? So we have that as a finite state machine. And once we put that finite state machine, we have a small code generator that gets the code for that model of the phone. So Skinny or any stem, right? That so once we have the protocol encoder decoder as a different part, and we have a middle layer where we generate these FSMs for each model or each type of protocol, and that FSM is what drives our productivity basically. So we the FSM in a like basically a short language, and then from generate the C code.
Here, guys, it is on the one side, and we'll kind of walk you through, is we have Skinny telephones, some extensions Skinny telephones. Along the way is we have extensions on the MX1 platform. Good enough to get that set up on that side. And what we're going to do is messages very quickly. So along this, see the Skinny messages come in, we collect those. We look at them, we do a mediation over to the SIP layer. And along the way is we go ahead and send those messages over to the MX1 platform in order to get through. So we're going to do a pretty basic, make the phone ring, go ahead and put the call on hold, and then head and end the call. To show you what we can do. From it comes down to is us just continuing with the mediation engine in order to do the other services, like conferencing, three-way conferencing, and Tony sent us a list of things. But how we built the first part of this, and I think it will show really quickly how we can do the rest of it.
Hey, David, let me ask a quick question, if you don't mind.
No.
And are you supporting the entire Skinny or some subset of the Skinny protocol?
So right now we only captured kind of the setup messages, the stop messages, the hold messages.
Yeah.
But for the rest of it, again, what we're looking to do is we're looking in order to build out the team and to be able to go ahead and do the right. So our goal would be to deliver not only the entire Skinny protocol, but the entire Skinny protocol for all the different variants of Skinny depending on the telephones.
Yeah, so really this is a proof of concept that Cass and David have put together. So like a minimum viable demo. So the challenge we set them was, let's choose a phone and let's see whether you can do some high run intro. Yeah, if this proves, we would make a deal with Kaladas and David to invest and out to a full product.
No, well, the question becomes, I'm just wondering if, are you CSTA as kind of the minimum spec or something along those lines? In other words, Skinny was I used to actually have Skinny code at one time. There's a lot in there. And, how far do you go? And reasonable.
Sorry, Kyle, that's a great question. And along the way is, again, I think we've started the discussions, and again, we're looking at it. And one of the first things we determined was just how chatty Skinny is.
Yeah.
So it was creating a micro that went ahead and it was basically a proxy to collect that information and determine, hey, by the way, when does it make sense in order to then go ahead and push that, the architecture slide. So why don't you check how it does?
Yeah, very, very noisy, and we've played it and tried it even on satellites and stuff like that. It's almost impossible. Right.
The thing about it is that's when we discovered, again, with no knowledge, is we discovered that right on, and what Kaladas will take you through is having a collection that says, okay, by the way, is a bunch of chat, okay, this is now a full command. Now let's go implement that and mediate that over to SIP.
One other thing, Richard, is I think Tim was just telling me that obviously with Cisco, you could flash it to standard SIP from right, and then you get maybe get 10 features, but you don't get those proprietary features. Now potentially with the VNE solution here that the guys are showing us, we actually build the mediation for all those proprietary features. Now when you go to a Nortel Unistem phone, that's when the game starts changing because you can't refresh a Unistem phone to SIP. So you can make those Unistem protocols now converted into a Mitel standard language. Then we can take the Nortel PBXs out of the game and keep the phones in play, which is what customers want, right?
Yeah, no, exactly. And the question is, Tony, is how far do you you need to support everything?
Probably like maybe there's 10 features that cover 80% of people. They want to be able to transfer, conference, park, retrieve.
So the big thing is that the user experience can't change. It's not just the phone set itself, which is certainly part of the discussion, but the phone, so that no additional user training is also the key piece here.
Right.
So that means that we can use the previous project we worked on called Blue Gateway as a list of features that would be probably pertinent to this situation. Do that one day, but that's just a list of features that would probably be worthwhile exposing because somebody's already done that work.
Yeah, I think the thing is that the technology that Kyle's going to demo, allows us to do that. It gives us some options. So maybe, Alice, do you want to move to kind of explaining the demo and then doing a demo?
Yeah, just I wanted to highlight that earlier we didn't have that slide. So what is basically it could be any protocol like diameter, SIP, or Skinny. What we have is a protocol. First, right, is a protocol encoder decoder, and middleware. This middleware we create these finite state machines. So based on the actions that need to be there, so we create a finite state machine, and this is what drives your features. Bottom is what we have is a persistence layer. So this is logic on how to do the number translations, all those things. And on the right hand side is the management, basically that monitors these containers up, down, and then basically your human interaction with the machine. So it supports the netconf and redfish protocols, and it also for everything. We also have a REST API. So when you want to add a enterprise with 100 extensions, so you can add a Excel file, and then you automatically program the persistent layer on those entries.
The next part of my questions will be how it's segregated for different customers for security reasons.
Yeah, and again, there's a security layer we can add in order to kind of do a multi-tenant approach, or again, microservice layer is you can basically just turn up an instance per customer. And that way you have full definition.
Exactly. Yeah. Appreciate it, Dave. That's what stuff I was looking for. Thanks.
Yeah.
So here the microservices is that David mentioned earlier. Here, this is the key component that has a skinny tip, and so basically all other components remain same, and these components keep varying. So we will have Unistream component or Unistream cluster, Mini cluster, and our SFB clusters, and the management layer will be the common one that will be monitoring all these clusters.
Yeah, and what it means is, we can kind of take you through the demonstration. We have for diameter is a way you start to see the peak of it. Is it's out, and it says, hey, by the way, I need to go out and get resources in the cloud to go get more. I need to go get more CPU computation, more memory. So elastic in that part of it. So, you guys are looking at microservices. You guys are looking at a way in order to kind of move that. This is an architecture that allows us to play right in the cloud and kind of hands off. Say, hey, take the swells when they come. And as it diminishes, we'll hand back the power back into the cloud. So not to overcharge you guys. So just taking through the demonstration. It's going to bring up a lot of questions, and I promise I'll go on mute because Kaladas is a smart guy here. Okay.
So it's like I'm starting with so this is current. So I'll line up.
Well, I'm sorry. When you do it, why don't you tell them what the IP addresses represent? That way, just go off hook and then show them what the IP addresses, so they can write it down, so they can know what it is.
So I'm going off hook. So as I go off hook, the skinny phone connects to the server. So the messages. So this is the is there, and this is the skinny phone, like my address of the internet, like the public IP address, and the skinny is contacting the server. This is our
Who's serving that?
the DNE.io server, the proxy, that is the SIP proxy,
Okay.
and it's there. The skinny to SIP proxy is basically contacting your server. This is your mx mytel.com.
Right? Like software is generating this signaling ladder diagram, or are you using Wiarc like this is like, so the phone is sending these messages, your machine, your server is capturing it, and then creating this ladder diagram. Is that software or?
Yeah, it's our software. So what we did is that the protocol encoders and decoders here, that's what they do. And what we do is initially in the development, basically there is a way to see only for particular phones. Let's say only X. So we have monitor subscriber feature. You only for the specific the customers who are complaining. But the development cycle we have opened it for everyone. So any message that is coming, we are putting it on the here our browser. So if you have thousands of phones, use for those specific. So there is a entry here in our UI. We can program which subscribers call flow messages you want to monitor. Then all those messages will come there.
So this is all our code, and you see it all just configuration amongst a couple of handsets. Is part of the support comes down to is we have a one-touch support, whereas you go and say, hey, by the way, I'm having a problem with these IP addresses, these telephone numbers, and this is the stuff that with a one button that we're collecting all the Wireshark, all the PCAP files, all the traces, so that we hand it back to Mitel support. It is, by the way, Dave is having a problem. It's this telephone's having a problem connecting to the Mitel cloud, and all the that developers and support need comes right back to them.
So this is basically, this is super Wireshark, right? Because Wireshark doesn't give you anything like this. I mean, when we were working with the Sonos guys, David, we asked for ladder diagrams. So, I mean, and then so software, basically generates those nice, logical kind of signaling call flows and ladder states, so you can actually see what's happening. Okay, great.
And this comes from Khaled Payne. Khaled, early in his career, would wait customers for 3 or 4 days to kind of collect all the information so he could kind of troubleshoot it. So one of the first things he did was said, hey, by the way, I'm going to make it set with one is all the data is collected and handed back to the corporation to troubleshoot this. I won't steal your thunder anymore.
Yeah. So now I'm all with Ilya. He's calling me from his soft phone. So the message. So I got the invite. So calling 2006 and 2007, and here are the messages. So he me, and I can hear his voice. Yeah, I can. Yeah. So like as soon as I terminate the call, so basically the call terminated. So bye, and then now after this there will be only just between Skinny and server, the proxy server. There won't be messages from the SIP server. So but it will be keep alive. Actually see these messages in a tabular format. So okay, and then I click on that message, I'll get more details of that. And also have connectivity diagram. Basically, see this is phone has a corresponding IP, like so the this 2007, that is a phone, and so basically you can think of this phone as two parts. One is the SIP that is on the right hand side, Skinny that is on the left hand. And so Skinny is a asymmetric protocol. Basically, the number of messages received and sent is totally different. So sometimes you have more from the server to the phone. So here also, in future you will see only for those customers you want to see. Otherwise, you will see basically the link diagrams, the link between the and the SIP server, and link between the client and the proxy. So this can be replaced with the IP global IP address of your enterprise, the customers where they are calling, and aggregated like message counts requests, and here it will be basically between the SIP server and the proxy. But for we've opened up a little bit more granular so that we can see.
Okay, there's another question. Skinny protocol. Do you have any licensing issues?
What happened is basically we will going forward need more guidance, means more up-to-date documents. We have documents from the internet, and then actually from the ground up. So we are not borrowing any Skinny code. We coded it basically using that protocol encoder and decoder. Coded from the ground up. We won't get the leverage from the DPDK. Basically, the Intel's DPDK, the bypassing the OS kernel, and whatever that David mentioned, that 250 microseconds or lower latency is possible only through DPDK.
Yeah.
All right.
So Kyle, answer the question.
Tony, I mean, it's something.
Sorry, answer the question. We don't have any issues with that because again, we're not going ahead and importing Cisco's code in order. We're watching messages between a Cisco end device in this case, and then basically we're doing ahead and copying and developing our own code. So we don't see any issues here.
All I just let you know, when I did work for Cisco, the Skinny protocol was such. It's almost like the Coca-Cola recipe. I mean, they were paranoid. Mm-hmm. So if they suspect that we're back reverse engineering it, this is one area that we may want to look at to make sure that we don't get into trouble with this. I had to sign my life away in getting the Skinny code.
Yeah.
Hey, Richard, this is Wes. But wouldn't you just wouldn't you just be upfront how you did it up? I mean, it essentially is a mediation gateway. That's my just hearing you. That's my headline.
It is. Wes. I just want to just be careful if we don't get too far down this path and Cisco comes after us.
The lawyer in me here's clear. The marketer in me says, "Guys, go bullying customers again. Creating a locked world for you. That would be a marketer's dream." But
no, of course, Wes. I just know that I've dealt with them and how serious they are about this.
Richard, like even if Cisco changes the protocol, right? Like with the architecture, we can adapt it. So they're not hacking Cisco, right? We're just doing Cisco as is. And we're not doing anything to break intellectual property, right?
No. I understand exactly what's happening here. I get it. I'm just all I'm bringing up is I'm not trying to be a skies falling kind of person. As you guys know, I'm pretty optimistic. But what I had to go through and to deal with to get this done.
So we'd need to find a pretty strong IP.
We got one. Michelle will get her to look at this. Yeah.
Look at it. It may be nothing. And David's right. Maybe this is trivial. I just want to make sure before
we have our little toy, right? We've actually looked at it, and he reversed engineered everything from scratch, and they felt like we had this one. We're not reverse engineering. We're just in the state that's given to us, right? I'll tell to look look at this, but I think I think this is. I mean, I don't think Cisco covers.
Okay. And Tony said is I think you guys all understand it is by setting the different microservices based on the different flavors of Skinny, which correlate to a telephone. If they're made either globally or to handsets, is we walk messages, we chain layer, which again happens very quickly, and we restart that microservice. So is Cisco rolls out a brand new firmware version. Your problems with, let's say, call hold, is they look at it and say, okay, by the way, we see the changes they made, changes in our mediation engine. We do a test on just that microservice, and then we reinvent it. So we go from you guys being down for months while you guys write a node for monolithic to in a couple of days for us to go ahead and do it and bring it back up.
No, David, that part I get. Absolutely. I mean, this is pretty clever.
All right, Cal.
We have right now detected the calls, right? So the conference calls is basically have problem connecting another. So one and with the conferencing part 2. So the call hold and unhold, we were just testing earlier, so we need time to basically demonstrate the hold and unhold.
So I think what we're going to show you guys is just again is the Skinny over to the SIP mediation layer. You can go ahead and continue to do the development in order to do the hold. And the way is I know Tim was making a change on your guys' side in order so we can get a different extension in order to conference capabilities. So we're good about conferencing as soon as we get the other up and running, and we'll hold as well. So questions, concerns? I mean, I think Richard brought up a great concern. I'm interested in going into a courtroom at Cisco. Questions or comments you guys have about the solution?
I think this would be a very interesting opportunity for us in the marketplace. And Tony and Wes, we got to figure out how it fits into the API platform. But I can see how it I just need to kind of cuddle this over a little bit. I don't know if it would make the connections, but this is a very powerful story.
Great. And it is, before I met Kaladas, it doesn't apply to you guys, but he built an entire diameter stack, the DEA and DRA. It is through friends. He also built it for Radius. So, when we think about this platform, we think of it as not just, scanning. We think about there's a lot of signaling that's out there that doesn't generate a nickel of revenue, but if it doesn't, it obviously impedes revenue. And is that the vast majority of those solutions are housed on hardware platforms, or they're deployed on virtual platforms. The way is this is an example of we built out very quickly, and we were able to show people exactly how we were able to do diameter. And the ways we did another demonstration in front of the customer to show them Radius, because for example, have a problem whereas they are Wi-Fi service in Manhattan, and Toronto, and Paris, and they 2 1-hour busy periods of time where they go from about 18,000 registrations per second to 150,000 registrations per second. Along the way is they deploy lots of boxes to be ready for the swell and pay. Whereas we kind of happen on the microservice layer, we scale up, we deal with the traffic. When people are going to work in the morning or going at night, and then we come right back down. So the money we save them in microservice layer was immense.
Okay. So you have New Hampshire?
Correct.
Okay. I love it.
To tell you, we thought we were going to die when our internet was down, so trust me.
How about this, or your team?
Yeah, team is right now we are 4 people active, and we have 2 consultants where we take them help on the need kind of. So 4 people active full time and consultants.
Okay.
In retrospective, it is the team had no domain. I had before no domain knowledge on any of the UC applications. So I'll be honest, we stubbed our toe in a couple places. And thanked him helping us. On the way, this is a perfect example is having, on the we had a design engineer or an on the way is when you start to see the message coming in. This is what you expect for us to create the entire STEM layer, the entire skinny layer is very, very fast.
Yeah. No, this is very cool, David. I think it's interesting.
Yeah.
Hey guys, by the way, Wes, I pulled Wes in. He was walking past my office. I said, Wes, you got to come and look at this, right? So this is really good. I mean, what you guys did. I mean, so ask me, how many hundreds of people work on it? No, it's Calvin, Dave, Ilya, someone in Bulgaria, and someone in Israel.
This team to do this would really count us and Ilya. That was the team that was doing this. And along the way is just to we were having an issue. We reached out and to a consultant to help us. And his team said, "Oh, hey, by the way, I think I'm giving you guys the wrong IP address back. That's correct, Tim. We'll give you an internal address. As soon as the public address, it was up and running. So we stubbed our toe on not understanding a couple of things. But the way is, I think this is a perfect example of with domain knowledge, develop this stuff very, very quickly. And as I said, Tony, is what we're looking to do is find funding so that Kaladesk can build out his organization properly, deliver solutions to customers.
That's really appreciated. So yeah. So what I'll do, I think I think Richard and Phil. I mean, so what's your readout? Like, from your perspective, do you see this as having the things we know, or do you just be frank, right?
Okay, I'm Richard. I already gave comments. I like, and we just need to figure out how to incorporate into the API platform. But it's, I think, a story.
Okay. Yeah. Great.
Send me some suggestions via instant messaging, Tony. This was looking for when you first said about it. The initial one was let's do SIP to SIP, and that was skinny to SIP as much more thing. Unify, Unistim, things would open up different markets for us. Cloud is great. Large enterprise perspective, I want to ensure that there was also a version we could put into a large private cloud, equivalent of CPE.
I think right. MX1 would be. I mean, as you go for those large, customer bases. I mean, now the MX1 can actually play, right?
Well, MX1 from a CPE perspective, and I'm talking about the United States in particular when I'm saying that, but also Telepo from the cloud perspective.
Yeah.
But Tony, I think this would be very interesting since it works with the VIVEs and Unifies and things like that from a signaling perspective. To get the handsets involved would be very interesting because about the little port part, so that's a gateway between and I just think about I just need to think about how we would plan it, but I think this could I think this could really add to our story.
Something I'm thinking, right? Because if with the Cloud Link, by the way, Wes is calling it Cloud Arch. That's his marketing name. So I'll tell you about that later. But with the Cloud Link, you still need that PBX there, and you still have to pay potentially maintenance and support.
Correct.
And what this lets you do is zap that PBX, that competitive PBX out, and keep phones. And now the phones are working on the Intel system. Either for MX1, My Voice Business or whatever. And we can now overlay, like, I think one of the things that Tim highlighted is all the apps, right? All the applications we can now deliver through the Mitel API platform and the PBX. Guess what? Those will now be, you know, native, being given those apps, right?
Tony, I've got another aspect to it. I'll share this with you a little bit later on what we're doing with the hockey puck.
Okay. Hey, David, this is brilliant. Thanks a lot. So I'm going to start. I think the 1:30 demo, Easton, let's keep that.
Sure.
I'll give you a call back because Wes and I are going to go talk to Rich, right?
Okay. All right. I'll be on that demo, Tony. Since I've seen everything, I don't need to be on that.
Okay. Thanks, Richard. Thanks, Phil.
Okay.
Yeah.
Thank you, guys.
Bye.
Yeah.
Yeah, great job, guys. Good. And if you could send me the link to the recording, it would be great.
Sure.
So that other second number thing should be in now. I hope it is.
I'll test it. Yeah.
Great, Tim.
Yeah. Thanks. Yeah. Bye.
Thanks, guys.
Goodbye.
Goodbye.
So